Welcome to Ms. Taylor's class notes. Today for Algebra 1, we're going to be talking about function notation. So first, let's talk about standard notation. Standard notation is basically what we've been seeing this whole year. It's an equation with y and x. So they might look something like y equals 3x plus 7. And so today we're going to talk about our function notation, which is an equation still with x, but we also include our function notation, or f of x. So it's going to look something like f of x equals 3x plus 7. And so all we're doing really is we're switching, or we're changing the y to f of x, and that's what we call function notation. If it's standard notation as a y, if it's f of x, it's function notation. So the next thing we need to talk about is input and output. Input is always going to be our x. Output, go away. Output is going to be our y. It's going to be our f of x. Our output is also going to be our dependent variable. And later when we talk, it's going to be our range, which makes x our independent variable. And again, when we talk later, it's going to be our domain. So for the purposes of today's notes, everything that is an output or is a y or an f of x, I'm going to highlight in green. Everything that is an input or an x is going to be highlighted in blue. So I'm going to real quickly switch to page 2, because page 2 sometimes is easier to understand than page 1. So the first thing I really want us to focus on is at the top of our page. When we talk about function notation, we're talking about points. We're talking about x, comma, y. We're talking about input. We're talking about output. So our input and our output are always linked together. And again, our y is simply our f of x. So here they have given us f of 5. So normally we write this as f of x. So our input is our 5. So that means that x equals 5. And so what we're looking for is we're looking for whatever our y value is when x equals 5. So if our point is 5, where are we going to find our y? So what that means is I'm going to come find 5 on the x-axis, because I know that my x is 5. And I'm going to trace it all the way until I hit the line, and I'm going to stop. And I'm going to take that line, and I'm going to trace it to the y-axis. So that tells me that my y is 9, or that f of x equals 9. And so again, f of x equals 9 is our output. It's our y value. F of 5 is our input, or our x value. So we're going to do the same thing over here. This f of x, so that tells me that my input or my x value is negative 4. So I'm going to find negative 4, stop when I get to the line, and then I'm going to trace over. So our output or our y value equals 4. But again, we write it like this, f of x equals 4. And so our point on the graph is negative 4, comma 4. So it works the exact same way on our tables. F of x is 2, so our input is 2. So we're going to come on our x-axis, or our x side of our table, find our input, and then we're going to find our output, or our y value. So f of x equals 27, and that's our answer. So I want you to go look at these next two graphs, look at which input they want, and find the output, and check it with our class notes. All right, so now let's talk about how we usually use function notation and how function notation usually works. So again, f of x is what we're talking about. So we've got our input value, which is our 24, and we're going to highlight all of our x's because those are all of our endpoints. So f of 24 equals 1/2. And what it tells me when we replace the x with 24 is I'm going to put the 24 in place of the x, and then I'm going to add them together. So now I'm going to pull out my calculator, and we're going to do this. So we're going to type in alpha y equals, we're going to hit our fraction, we're going to go 1/2, Then we're going to go parentheses 24, parentheses plus 7. And so this tells us that f of 24 equals 19, or f of x equals 19. They are both technically correct, but for later, I'm going to write it like this. So our input is the 24, our output is 19. So if we were to write this as a point, it would be 24, comma 19. So now let's hear our equation's a little bit scarier, but it's really not that scary. Again, I'm going to find my input, and I'm going to highlight or circle all of my x's. So when I write my equation, f of negative 4, I'm going to input my input in all of the x spots. So always, 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 whatever I put in the x spot, I'm going to put in parentheses. So plus 3, negative 4, and then finally the last part. So again, we just have to type this into our calculator. 3, parentheses, negative 4, parentheses, squared, plus 3, parentheses, negative 4, parentheses, plus 4. And so our answer, or our f of negative 4, equals 40. So if we write this in our function notation, f of x equals 40, and that's going to be my output. So again, my input is my x value, so negative 4. Our output is our y value. All right, I want you to try this one on your own and check with our class notes. Input the negative 12 into all of the x spots, plug it into your calculator. All right, so this one is a little bit different. This one gives us f of x equals 16. So what f of x equals 16 is, that is my output. So I'm going to replace my y, or my f of x, with 16. So that means I'm going to put the 16 in the f of x spot because I do not know what x is. I do not know what my input is. And then I'm going to write the rest of the equation. So I'm looking for the output, or I'm looking for the x. So that tells me that I need to solve my equation. Minus 7, we get 9 equals 3x. And our last step is to divide by 3. So 3 equals x. So my input is 3. So again, if we were to write this as a coordinate point, our x goes first. Then we put our y, or our f of x, and that is our xy point. All right, I want you to try this one on your own and check with your class notes. And then I also want you to try this one on your own, knowing that this is our output. And so we're going to replace our output while looking for our input.